In this lesson, I will explain to you about Chebyshev's theorem. Chebyshev was a Russian mathematician and he proposed this theorem. So first I will give you a little bit background of the variance and standard deviation. Then we will come to Chebyshev's theorem. Then it will be much more easy to understand. The variance and standard deviation, as we have discussed in the last few lectures as well, can be used to determine the spread or dispersion of a variable. We see with the help of variance and standard deviation how our data is spread regarding to mean. That is, the larger the variance or the standard deviation, the more the data values are dispersed. Suppose if we have two variables and both have the same mean. Suppose I say both have 60. 60 is the mean of both variable, while one variable has a standard deviation 2 and other is 12. So we will see the variable which has 12 standard deviation, that data is more variable compared to first one. So Chebyshev, the Russian mathematician, specifies the proportions of the spread in terms of the standard deviation. Chebyshev theorem is a fact that applies to all possible data sets. It describes the minimum proportion. See, the focus is on minimum. It gives the minimum range, minimum proportion of the measurements that lie within 2, 3 or more standard deviations of the mean. So see here 2, 3 and more standard deviation. The proportions of the values from any data set that fall within k standard deviations of the mean will be at least, and this is the formula he used, 1 minus 1 over k square, where k is the number greater than 1. See, it should be, k should be greater than 1. If I will put here 1, so it will be 1 minus 1, 0 over 1. We cannot calculate further, right? So that is why always k is a number and it should be greater than 1. So he calculated that if we put 2 standard deviation instead of k, if we put 2, then make the square of 2, which will be 4. So it will be 3/4, or we can say 75%. 3/4 is equal to 75% at least. If we have a standard deviation of 2, so at least data should be spread 75%. It starts from the 75%. If we put 3, k is equal to 3, then make the square of 3, which will be equal to 8 by 9 or 88.89%. At least this is the minimum, right? If we have a standard deviation 3, then 88.89%. If we have a standard deviation 2, then 75% minimum. This theorem states that at least 3/4, 3/4 means 3 by 4, which we had calculated in the last slide, or 75% of the data values will fall within 2 standard deviation, right? If suppose we have this graph and we have a mu here, mean here, so 75% of the data will fall within 2 standard deviation. 2 standard deviation on the right hand side means 2 sigma, or 2 here on the left hand side. I will show you how to calculate on the next slide, but keep in mind that 75% of the data values fall within 2 standard deviations of the mean of the data, while 8/9 or 88.89% of the data values will fall within 3 standard deviations of the mean, and so on. So these are the, suppose I have calculated only for 2 standard deviation k. If k is equal to 2, so this is the formula, 3 by 4, which is equal to 75%. And this is the same, 1 minus 1 over k square, it is equal to 88.89%. If the standard deviation is 2, 75% of the data will fall within 2 standard deviation, and then so on. And this is the important point of this theorem, that this theorem can be applied to any distribution regardless of its shape. See, empirical rule, which will give us the accurate result, we will discuss in the next lesson. The distribution is always like a bell shape. Bell shape means if we have a mu here, same amount of data you can see on the right hand side, same amount of data is spread on the left hand side. But this theorem can be applied to any kind of distribution. See, if I will make a line, so how it is not a bell shape, it is not a rectangular shape or J shape, any shape, it's different. So any, it can be applied to any kind of distribution. This one, this is the mu, suppose, right? So this one, mu plus 2 sigma, mu minus 2 sigma. If we have a standard deviation of 2, so data lies, 75% of data lies in this range, and we will use this formula, mu plus 2 sigma on the right hand side, mu minus 2 sigma on the left hand side. If it is 88, if we have a 3 standard deviation, so 88.89% data lies in this range from here to here. This is called the Chebyshev theorem, 75% and 88.89%. Suppose here we have two variable, variable 1, the mean is 55, both have the same mean. Standard deviation, one has 1.3 and other has 8 standard deviation. Right, so what it says, 55.2 sigma. If it is, this is 75%. 75% means 2 sigma. 55, this is the mean, plus 2 sigma, 1.3 is 57.6, 55.2, 52. It means that 75% data lies between 52.4 and 57.6 in this range. Right, in for this variable, if it is a standard deviation 8, then 75% data lies between 39 and 71. We have calculated like this. In this graph, this is plus mu plus 2 sigma, mu minus 2 sigma. Right, one time you have to plus this sigma standard deviation with 2, and here is 2. So we have calculated that 75% data lies between this, and in this case between 39 and 79. These values are found by adding and subtracting 2 standard deviation from the mean. This is the mean, by adding 2 standard deviation, right, and minus 2 standard deviation, similarly plus and minus. So we will find out the range, that 75% data will write what range, this range, 52.4 to 57.6. Here I have set another example with the 3 standard deviation. Mean is 55, same thing, standard deviation is same, but here you have to find out the range. So if it is a 3 standard deviation, then our data will lie 51.1 to 58.9. 88.89% data lies between this range. These values are found by adding and subtracting 3 standard deviation from the mean. Here I have set few examples to understand this theorem. Suppose the average mean income of a small town is 35,000. Suppose there are 2,000 people or 3,000 people, whatever, but their mean, see, average or mean income is 35,000 per house with the standard deviation of 3,000. What percent of homes can earn between 3,000 to 45,000? What is the percentage, right, that homes can earn between 30 to 45,000? So solution, subtract the mean from the largest value. This is the largest value, 45,000, and what is the mean, 35,000. 45,000 minus 35,000 is 10,000. Second step is you have to 10,000 divided by this standard deviation 3,000, so we will get 3.33, and this is the value of k. And our formula is 1 minus 1 over k square. So instead of k, now we have to put 3.33. I told you if we have a 3 standard deviation, then 88.89% data falls, right? Between 3 standard deviation. But here is 3.33. It means our answer will be more than 88.89%. So make the square of 3.33 and calculate it. So we will get 91%, 91.07% homes can earn between this range. One more question of this theorem. The mean price of a shop is 60,000 with a standard deviation of 12,000. Mean price. There are suppose 10 shops, 20 or whatever the number of shops, but the mean is one shop you are selling in 30,000 and 40,000 and 50,000. Mean is 60,000. Standard deviation is 12,000. Find the price range for which at least 75% of the houses, here you have to make shops, right? Because we are shops will sell. So solution 75% means that 3/4 of the data value will fall within 2 standard deviation. 75%. If it is 88.89, it means 3 standard deviation you have to take. Here is 75%, it means you have to take 2 standard deviation. So mean plus 2 sigma, mean minus 2 sigma. Calculate it. So you will get 36,084. 75% of shops will sell at a range between 36,000 to 84,000. Make the total of this divided by 2. You will get 60,000 mean, but the range is between 36,000 to 84,000 if we have a 75%. If here instead of 75% we have 88.89, so instead of this 2 you have to take 3 sigma and then you have to calculate. I hope this theorem is clear. If you still have any question, write down in comment section, and thanks for watching.